Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're continuing with critical path analysis, our fifth video. We want to do three things in this video. I want to be able to calculate the float of an activity, I want to determine the critical activities and what's something called the critical path, so I should write that in as well, the critical path as well. And we want to be able to draw a Gantt, or another name for it is a Cascade chart. So let's start off with where we got to at the end of video 4. At the end of video 4, we were able to draw an activity network and with dummies, etc. in there. And we were also able we had a brief discussion at the end. We talked about the forward pass in order to calculate the early event times and the backward pass to calculate the late event times. And we had a little discussion about float and critical path, but I want to take that further and make sure we understand it. Okay, the float of an activity is defined as follows. So the float of an activity is defined as the amount of time that the activities start may be delayed without affecting the duration of the project, of the entire project. So you should copy that down. And there's going to be a way of calculating it. So what we do is, say we had, let's just draw a picture so it's easy for you here. Say we had something like this. Say we had, I don't know, say we had an activity C which was 3 long, and we had an event 7, 8 here, 8 like that. We would calculate the float using the following formula. So our float would be equal to the latest finish time of the activity, subtract the duration of the activity, subtract the earliest start time of the activity. I'm going to write of activity in here just to make it clear. Latest start time of activity, duration of activity, and this in this case is activity C, and earliest start time of the activity. Okay, so in this particular case, let's just see what that would be. The latest finish time, let's highlight that in yellow here, the latest finish time of this activity C, the time at which you can leave here without delaying the project, is going to be the 8. Subtract the duration of the activity. So the duration of the activity is going to be 3. And the take away the earliest start time of the activity. This activity, the earliest it could have started is equal to 4 here. You could have got here at 4. So it's going to be 8, subtract 3, subtract 4. And what is this telling you? In the case of C, well, it's telling you you could have got here in 4, okay? Your activity was 3 long, so that would take you to 7, but you have to leave here by 8. So you've got a float of 1. You've got 1 spare hour. You could leave here at 5 and not delay the project. So in this case, it would have been 8, subtract 3, subtract 4, which is equal to 1. So the float of this activity would be 1, as follows. So that's telling you you've got 1 hour to spare. If you get there at 4, you can leave at 5 and not delay the project. So that's what the float is. So what we're going to do is, we're going to come up here and we're going to calculate the float of each of these activities. Page, I'm going to calculate the float of each activity. So let's do activity A. So it's going to be 4, subtract 0. So 4, subtract 4, subtract 0, which is equal to 0. No float there. For activity B, what would it be? Well, it would be 12, subtract 3, subtract 4. 12 subtract 3 subtract 4, which is going to be equal to 5. Let's just make a sense of that. Obviously, you can get here at 4. Your project's 3 long, your activity's 3 long, so that gives you to 7. But as long as you leave here by 12, you don't delay the project. So you've got that extra slack of 5. Activity C, well, it's 9, take away 5, take away 4. So 9, take away 5, take away 4, which is 0. Activity D, 14, take away 2, take away 7. 14, take away 2, take away 7, which is going to be equal to 5. Okay, you get here at 7, your project's too long, which takes you to 9, but as long as you leave here by 14, you're fine. So that gives you a float of 5. So let's do E, F, what do we get to here? G and H, G and H. So we'll calculate the float of each of these. Let's have a look at E. 12, take away 3, take away 9. So 12, take away 3, take away 9, which is going to be 0. F is going to be 14, take away 2, take away 12. So 14, take away 2, take away 12, which again is 0. G is 16, take away 3, take away 9. 16, take away 3, take away 9, which is going to be equal to 4. And H is going to be 16, take away 2, take away 14. 16, take away 2, take away 14, which is equal to 0. And they're the floats of each of the activities. Okay, so let me just pick one at random here. Let me, just to make sure you fully understand what this means. Let's pick this one here, C, and let's pick this one here, G. So let's look at C. Go up here to C. So I want to look at C here and what this is telling me. Well, for activity C to start, I can get to this event at 4. Okay, and the event takes 5 long, which will bring me to 9, and I must leave here by 9 or else I delay the project. So this one here has no wiggle room, no float at all, and so when it's got a float of 0, it's called a critical activity. As follows. And let's look at one here, G, which has got a float of 4. So let's look at G and try and describe what's going on with the float of 4. You can get here at 9 and your activity is 3 long. So in theory, if you left at 9, that would bring you to 12. You have to get here by 16. Okay, so that gives you the float of 4. So it gives you some slack of 4. So you could leave here 4 hours later at 13 and you wouldn't delay the project. So that's a non-critical activity. So it's not critical. Okay, so a critical activity, this is something we should define down here. A critical activity, well, what would that constitute? What does it mean for C to be a critical activity? Well, a critical activity is an activity where any increase in its duration would increase the length of the project. Or the time of the project. So that's what's called a critical activity. And you know it because it's always got a float equal to 0. Okay? So let's look up here, and this one's clearly critical. And this one's critical. This one's critical. And this one's critical. Okay, so let's highlight those in. So I'm going to rub out what I've done here. And in yellow, I'm going to highlight the critical ones. So the critical ones are as follows. So we said activity A is certainly critical. We said activity C is critical. We said activity E and F and H are critical. So E, F and H are critical. And that's it. There are critical activities. Now, a critical path, we need to define something called a critical path. Critical path. And it's a path from source to sink nodes along just critical activities. So in this case, the one I've highlighted, A, C, E, F and H, so A, C, E, F and H is a critical path. Okay, right, so that was flow, and that was also helping us determine the critical path. So in my next part, I wanted to talk about critical activities and critical paths. It's the exact same diagram. Because these had a float of 0, that was critical activity, that was critical, that was critical, that was critical, and that was critical, because they all had a float of 0. So any increase, if I increase this to 5 long, it would delay the whole project. And the critical path was A, C, E, F and H, away from getting from the source to the sink entirely via a path of critical activity. So that would be a critical path and what critical activities are. So the key thing here from the previous slide is a critical activity has float 0. Okay, so I've done there, everything on this slide basically did what a float was and what a critical activity was, and I've just briefly gone over critical activities there. The last thing we need to do is what's called draw a Gantt or a Cascade chart from this. So what we do is we look back at our original working here, and we identified a critical activity was A, C, E, F and H, okay? And we're going to use that on our diagram here. So a Gantt or Cascade chart goes from 0 to the n times 16, and it's all we draw it along here are bars that represent the activities. Okay, so what we're going to do is you always draw the critical activities first. So A, you can leave here at 0 and you have to get here by 4 and leave here by 4. So 0 to 4 is going to be A. Now we go along the critical activities. You leave here at 4, it's 5 long and you get to here at 9. So this one's going to be 5 long and you get here to 9. That's C. Here's going to be you leave here at 9, get here at 12 and have to leave here at 12 and it's 3. Another critical activity like that. Here you get here at 12, leave here at 12, it's too long, you must get here and leave here by 14, so that's another critical one. So that there's going to be like that, and here's our final critical one as follows. So in a Gantt chart, the first thing you do is you do your critical part activities and path. So this is A, C, E, F and H. And now what you do, so let's highlight them to say we've done them. So we've done E, C, E, F and H. And now we've got to go and do all the other ones. Now let's start with B. Okay, you can get to B in 4, right, and it's 3 long. And we've calculated already that you've got to leave by 12. So what I do for this, you've got a slack, haven't you, here of 12, take away 3, take away 4, which is 5. So you can get here at 4, so I draw B getting here at 4, and I'm saying it's going to be 3 long, so it could go up to 7. And then what I'm going to do is I'm going to continue it, because as long as I've left here at 12, I'm going to continue it like that, and I'm going to make that a dotted line. That's like my float, as it were. So that's B. Okay, so we've done B, so let's highlight B. Now what we're going to do is we're going to go on and do D, that's not done here. So D, you can get to it at 7, and you have to have finished the activity by 14, okay? And the float here is going to be 5. 14 subtract 2, which is 12, take away 7, which is 5. So you start at 7, so here we go, we start at 7. We go along for 2 hours along here, but it could have gone all the way up to 14, which is essentially its flow. And I'm just going to make that a dotted line there. Okay, and that's activity D done. So starting at 7, have to have left there by 14 is too long. So there's D done, so we'll highlight D. And what else do I need to do? I just need to do G to finish off. So let's do G finally. G, you can get there at 9, so you can start at 9 and it's 3 long and it must be finished by 16. So let's just go down here. So you can start it off at 9. So we're going to start it off at 9. It's 3 long, so it's going to go over to 12 like that. And the float in this case is 16 take away 3, which is 13, take away 9, which is 4. Okay, so you've got a float of 4, which will bring you all the way up to 16, 1, 2, 3, 4, like that. And you make it as before with a dotted line. Okay, and so we're going to call that activity G. And so now we have listed all the activities. So we've done A, B, C, D, E, F, G, and H. We've done all the activities. We've laid them out on this Gantt chart. It starts at 0. It has a line for each extra hour, 1, 2, all the way up to 16. We've labelled the critical path, and we've listed out all the other activities, B, D, and G, and shown their float as well. So the float is these boxes here. So what this is telling us, it's telling us that we can move B, as long as it can happen anywhere between 4 and 12. So B can fit anywhere along there like that. What about D? D can fit anywhere starting at 7, that too long, anywhere along here like that. D can fit. And lastly, it's telling us that G can fit anywhere along here like that. Okay? But also it tells us something about what some of the things that must happen first. So C happens after A, E happens after C, etc. Is there anything else that we need in here? D obviously has to happen after B. So I can't go, if I, for example, move B forward like this, if I wanted B there, I can't have D there as well because D happens after B has happened. So I'd have to shift B along as well, you see? So you have to be careful about the dependencies as well when you're looking at these Gantt charts, okay? So there's my Gantt chart, there's the floats being shown, and you could be asked some certain questions. You could be asked the following. At, say, 3 o'clock, 3 hours in, what activities must be happening? So what you can do is you can draw a line down there, and at 3 o'clock, only A must be happening. What if they asked you at 5 o'clock what activities must be happening? Well, to look at it, you think C and B, but remember B could be moved. B could be moved along here. B does not have to happen here. It could have been moved here, so it's not happening. So you would just say in that case that only one activity must be occurring. However, if you had something like, let's say, again, there's no real space where, if you had something sort of here, again, only one activity is happening, activity F, because none of the others must happen at that point. Okay, so that's one of the things you could use a Gantt chart for. And lastly, what you have on your Gantt chart here is clearly, you can see that A, C, E, F, and H are the critical activities. These can't be moved at all, whereas you've got flexibility with B, D, and G. So these are the ones that have a flow, whereas A, C, E, and E, F, and H are critical. I'm going to finish this video off by doing one last example. One example for you to draw the Gantt chart from the activity network and for you to answer some questions in relation to that Gantt chart. So that's going to be on the next page. Pause the video when I show it to you and have a work through it. So here's the question. Read through that question and have a go at it. I'm going to go through it in 5 seconds, so you may want to pause the video and try yourself. Okay, so we're asked to draw a Gantt chart to represent the activity network here, and we're asked various questions about it. So the first thing we're going to do is, it starts at 0 and ends at 26. We're going to draw ourselves a grid, starting at 0 and ending at 26. And what we're going to do is we're going to work out the float for each activity so we know which items are critical. So before we do that, so that's our, there's where we're going to draw our diagram there. I'm just going to take a second to work out the float of each of the activities. So let's do A, B, C, D, E, F, G, and H. So we're going to work out the float for each of these. So for A, it's 7 subtract 7 subtract 0. 7 subtract 7 subtract 0, which is equal to 0. So this is going to be critical. For B, it's 7 subtract 3 subtract 0. So 7 subtract 3 subtract 0, which is 4, so it's not critical. Let's for C, 11 subtract 4 subtract 7. 11 subtract 4 subtract 7, which is going to equal 0. So again, it's critical. D, it's 19 subtract 6 subtract 3. 13 subtract 6 subtract 3, which is 4, so it's not critical. E, 18 subtract 10 subtract 3, so 18 subtract 10 subtract 3, which is going to equal 5, it's not critical. F, 18 subtract 7 subtract 11, 18 subtract 7 subtract 11 is 0, so this one is critical. G is 18 subtract 5 subtract 9, so 18 subtract 5 subtract 9, which is going to equal 5. Which is going to be equal to 4. So it's not critical. And H is 26 subtract 8 subtract 18. So 26 subtract 8 subtract 18 is going to be 0, so that's critical. So let's highlight our critical ones on here. Our critical ones are A, C, F, and H. So they're the first ones that go along the first row of our Gantt chart. So this is how it would go. A, 0 to 7. So A would go 0 to 7. B would go, looking up there, 7 to 11. F would go 11 to 18. And H would go 18 to 26. And we would label them in here. So that's clearly A, C, F, and H. Okay, now what we do is we put in all our other ones. Now B, looking at B, it could start at 0, it has to be finished by 7, and it's 3 long. So what we do is it starts at 0, it can go up to 3, it can go up, so it's 3 long, and it could go up to 7. And what we'll do is afterwards we'll make that like that. So that would be B. Now D must happen after B, so it's very important. D must happen after B. Now it could start at 3, it could end at 13, and it's 6 long. So it could start at 3, it goes up 6 places, so that would go up to 9, and it's got a slack of 4, we said, didn't it? Or a float of 4, so it goes up another 4, 1, 2, 3, 4, like that. Okay? And again, we could just highlight that as we see, like that. Okay, so that would be D done. Now E must happen after B as well. Now E can start at 3, it's 10 long, and it can go all the way up to 18. So then we go down to the next one, which is E. So E can start at 3, it's 10 long, so go up to 13, but then must be finished by 18. So it's got a slack of 5. So from here to here is the slack, or the float, as we also call it, like that. Okay, so we've done, we've also done B here, we've done D, and we've done E. Okay, what else? The only one we've got to do is G. Now G happens after D has happened, must happen after D. So it can start at 9 and end at 18, and it's 5 long. So it can start at 9, can end at 18, and it's, I think we said 5 long. So it goes up to 14, has a potential to go up to 18, like that. So it's 9, it's 5 long, like that. So it's got a float of 4, which is the reason for that 4 there. And we would just highlight that in the dotted line as follows. And that would be activity G. Okay, so there's our Gantt chart. So we've done the first part. We've drawn a Gantt chart. Then it says the following. So this is where we can use our Gantt chart. It says, use your Gantt chart to determine which activities may be happening at midday on day 5. So each of these are a day. Midday on day 5 is halfway in between, let's say, day 5 and day 6 are there. So which activities may be happening? What could be happening? Well, A could be happening, B could be happening, D could be happening, and E could be happening. So our answer to that one would be A, B, D, and E. Now, they don't have to happen, but they could be happening because there's the potential for them to be happening. Okay? And the next one says, which activities must be happening at midday of day 7? So let's go down in between 7 and 8 here. Which must be happening here? Now, C must be happening. You can see that. C is critical, so it must be happening. Okay, for part B. Now, D currently, maybe we could move it around. Let's see if we could. B is not in there. Maybe with D we could move it around, so it's not in there. It currently is. But even if we moved it here, it would still be happening at midday at that time. So D is a must. What about E? Could we move it? Sorry, D. Just checking D there. D still is must happen midway between there. What about E? Could we move it out of the way here with E? So if you moved it all the way to the end, then it doesn't necessarily have to be happening. So E doesn't have to be happening. So just D must happen. So I put C, and the answer would be D there. That must be happening at midday on the 7th day. Everything you need to know about 1, calculating the floats, 2, identifying critical activities, 3, identifying a critical path, and lastly, being able to draw the Gantt or Cascade chart and being able to use it to identify which activities must be happening. Thanks loads for watching.